In the quest to explore the universe, our greatest ally is the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. For as long as there have been people to look up, the night sky has been an endless source of wonder and mystery. It's easy to understand why. Like so much of the natural world, the stars, planets, and other objects that fill the heavens exist in plain sight. But unlike just about anything else, they also exist beyond human reach. For our ancestors, this made the night sky a supernatural place. A place they eventually filled with mythical beasts and the gods. In time, this mythical view gave way to a more mathematical understanding of the sky. But the stars remained as mysterious and distant as ever. Unable to touch the heavens, humans eventually came up with an ingenious device to bring the heavens closer. It's called the telescope. Although telescopes today vary in size and complexity, the underlying principle is always the same. At its heart, a telescope is a device that magnifies our sight. Using mirrors or lenses, and often both, it makes distant objects appear closer. In this way, the telescope can reveal details about our universe that are inaccessible to the naked eye. Equally important, a telescope is like a funnel for light. It's wider at one end, and it grows progressively narrower as it gathers and concentrates far more light than would otherwise pass through the narrow pupil of the human eye. And this is why, through a telescope, objects that are dim appear brighter, while objects that are too faint to be seen at all emerge from the shadows. Because it extends the power of the human eye, the telescope was the tool that finally allowed astronomers to see what kind of universe we live in. As it turns out, it's a far larger and deeper universe than our ancestors ever imagined. It was only after the telescope was invented that people began to grasp that our entire world is just one planet among many. And that our sun, in turn, is just one star in a galaxy we call the Milky Way. A galaxy that holds 100 million times the number of stars that can be seen with the naked eye. Thanks to the telescope, the Milky Way was itself revealed to be just one among billions of other galaxies. Great islands of matter and light adrift in a cosmic ocean that is as vast as it is dark. But for all the power the telescope brings to the study of our universe, for nearly 400 years, it was limited by a factor beyond human control. For Earth-bound stargazers, the atmosphere is a fickle window on the cosmos. Its constantly shifting patterns mean that our exploration of the night sky is conducted at the whim of the weather. Even on the clearest night, the air above Earth is always in motion, like a turbulent cauldron of invisible soup. This ever-changing turbulence bends and distorts the incoming light of stars and galaxies. Even for the biggest and best telescopes in the world, the fine details of our universe are blurred away. If the effects of Earth's atmosphere could somehow be eliminated, we would improve our view of the universe 100-fold. It would be the biggest single leap forward since the invention of the telescope. Took that leap. The Hubble Space Telescope was lofted into orbit aboard the Space Shuttle Discovery.
Lots of clearance. Coming starboard nicely. A little bit more.
Okay, let's do it.
Okay.
Years in the making, the telescope was named in honor of Edwin Hubble, the celebrated American astronomer who first proved that galaxies exist and demonstrated that our universe is expanding.
Okay, we have a go for release. Okay, Charlie.
With its unique status as the first large telescope to operate outside the limits imposed by the atmosphere, astronomers hoped that Hubble's namesake would lead them to equally important discoveries.
Houston Discovery.
Go ahead, Charlie.
Okay, Story, we've been taking marks. Residuals and ratios look good, and we'd like to go ahead and go to filter state.
Expectations were running high, but what astronomers saw was not what they expected. Within days of Hubble's launch, it became obvious that the telescope could not see properly. Images that should have been crisp and detailed were blurry. The problem was soon identified. A slight but fatal flaw in Hubble's main mirror meant that it was unable to focus incoming light. The flaw had been introduced years before due to an error in the way the mirror was tested during its manufacture. It had gone unnoticed until the Hubble was already in orbit. Fortunately, the Hubble's disastrous debut came with a silver lining. Because the flaw in its mirror was so well understood, it was possible to craft a precise set of corrective optics. It was the astronomical equivalent of contact lenses. The result was spectacular. After its dramatic repair in December of 1993, the out-of-focus images that Hubble had been beaming down to Earth were replaced with views of breathtaking clarity. The pictures were not only better, they were the best astronomical images in history. For the first time since the invention of the telescope, astronomers had a new way of seeing the sky. One that would change our view of the universe forever and fill our eyes with images of breathtaking beauty. The age of Hubble was underway. Sometimes the power of great art is the way it reveals the extraordinary within the ordinary. In the universe, there's nothing more ordinary than the death of an average star. But when seen through the Hubble Space Telescope, this unexceptional event becomes a scene of stirring beauty and rebirth. When a typical star runs out of energy, it cools and expands. Like a dying gasp, its outer layers are puffed outward into space, forming an expanding bubble of glowing gas. As the bubble grows more diffuse, the star's core is soon laid bare. It is now a tiny but intensely hot white dwarf star. The intense radiation it gives off energizes the expanding gas, which takes on the appearance of a luminous flower blossoming in space. It's called a planetary nebula because over a century ago, astronomers thought that the rounded shapes of objects like this looked like distant planets. For the Hubble, a planetary nebula offers more than an opportunity to study the final stages of a star's life. Each one of these colorful blossoms is unique, like a flower in a painter's still life. Among all the objects in the universe, they have added some of the most beautiful and breathtaking images to Hubble's collection. And they are as diverse as they are beautiful. While some are symmetrical and round, others have turbulent and complex structures. Here, Hubble zooms in on one of the best examples. This planetary nebula resembles a bow tie. Its complexity tells us that the nebula likely formed in a series of ejections, rather than one great outburst. this is also true of the Cat's Eye Nebula. Astronomers are still trying to decipher the events that formed this unusual object. Near the center lies a series of intersecting shells that were ejected from the dying star over the past 1,000 years. Two jets of material have pierced these shells on opposite sides. Meanwhile, these structures sit within a larger succession of concentric shells, which were released over thousands of years in regular bursts and which now make up the outer portions of the Cat's Eye. One theory that may help explain the unusual shape of the Cat's Eye holds that the nebula's central star is not a single white dwarf star, but two stars in a close orbit around each other. The idea that the presence of a second star can greatly complicate the shape of a planetary nebula is already known from another striking example. Astronomers call this object the red rectangle. Here, it's believed that two stars are in orbit around each other, with a ring of dust surrounding both stars. When one star aged and began ejecting its outer layers into space, the ring became a waistband, forcing the material to move outward in two narrow cones rather than in a spherical shell. The Hubble can also show us many other examples of a planetary nebula with an hourglass shape. The cause of this shape may not be the same in all cases. Different theories suggest that the gravity of a companion star, large planets, or simply the interaction of gas with a star's magnetic field can explain their remarkable forms. Now, with Hubble's penetrating eye, astronomers are zeroing in on some of the largest and brightest examples, searching for clues to their formation and structure. They have good reason to be curious. A planetary nebula may be lovely to look at, but its true significance to us lies in the nature of the material it releases into space. The vivid color in this Hubble image corresponds to different atoms emitted by the dying star. In this case, the green light represents oxygen atoms, while the red color is due to nitrogen. The shells of stellar debris expelled by dying stars are not simply made of atoms, the basic building blocks of matter. They also produce molecules, combinations of two or more atoms, including molecules that are instrumental to the origin and development of life. In the past, it was believed that such molecules would be destroyed by the intense radiation from the white dwarf at the center of each planetary nebula. With Hubble's help, astronomers have learned this is not the case. Among the best locations to study this exciting new development is the Helix Nebula. It is one of the nearest examples of a planetary nebula to Earth, which makes it an ideal target for the Hubble. The catch is that the Helix Nebula is large, much larger than the Hubble's field of view. To capture the entire nebula, Hubble took many separate images, which were combined to make a grand mosaic. Normally, there would not be enough room in Hubble's schedule to dedicate so much time to a single object. But a few years ago, a passing cloud of meteoroids forced the telescope to be placed in a protective mode. In order to shield its vulnerable primary mirror, Hubble kept its back to the incoming meteoroids, and as a result, had to stare at the same part of the sky for many hours. Fortunately, that part of the sky included the Helix Nebula. So what has Hubble found in this incredibly detailed view? Like other examples, we find the Helix Nebula is composed of nested structures, one inside the other, each blown off in different episodes during the central star's transition to a white dwarf. But because the helix is so much nearer than other examples, astronomers can see much more detail within those structures, and they have a better chance to explain how they formed. One result of this investigation is that it's now clear the helix contains a pair of gaseous disks that are tilted with respect to each other. This reconstruction shows what the Helix Nebula might look like if viewed from another angle. At this angle, the two disks are more obvious. But exactly why they are oriented in this way is not so easy to understand. Perhaps, as in so many cases, it's because the star at the center of the helix is really two stars in one, which has complicated the structure of the expanding nebula. Even more intriguing than the helix's overall shape are the many tiny clumps of material that show up on the inner edge of the nebula's glowing rings. Astronomers have dubbed these objects cometary knots because they look so much like comets with their long streaming tails. These knots cannot be comets, however, because they are too large. Instead, it's believed they are denser clumps of material that formed within the expanding shell of the Helix Nebula. As the fast-moving stellar wind from the central star pushes outward on the nebula, the clumps are gradually exposed. But while the bright gas in much of the nebula is seared by the incredible heat of the central star, the molecules within the cometary knots remain protected. Here, carbon-bearing molecules can form and survive until they are eventually dispersed into interstellar space. This is why places like the Helix Nebula are cosmic flowers in more ways than one. After they blossom, they not only dazzle us with their fleeting beauty, as Hubble has shown, they are also scattering the seeds of future life.